Hope my slide presentation is visible to all of you. Can
Yes, Anita.
anyone confirm? Okay, thank you. So let me introduce myself. My name is Mitali. I'm the Red Hat certified architect and instructor of complete open source solution, which is acquired by the ProDevance technology. So today our webinar is on OpenShift. So I have more than 12-year experience in Linux and open source technology. As my favorite distribution is Red Hat Enterprise Linux, I did my certification on RHL 6 on 2014. I upgrade myself in RHL 8 in 2021 to take the training towards the next level. Including this, I completed my certification on automation and configuration management tool, Ansible. Another one is Puppet. Also be part of that training and delivery. I exposed to the Red Hat OpenStack Cloud and the Amazon Cloud AWS. Uh, and I certified on the OpenStack Cloud. Amazon one is pending in my bucket. So I'm delivering this training on OpenShift container platform since 2017. I exposed to OpenShift container platform 3.5 version. Then I completed my certification on 3.9 in 2019. 2020, I upgrade myself on the 4.2 version and enrolled as a trainer in this platform. So we are just once this webinar session is ended, you have to ask any query regarding your training, the duration, the lab practice hours, certification program, course prerequisite, everything I want to cover in this session. Still you have any doubt, you can let me back, you can put your queries in the chat window, so individually I just get back to you. So these all are the Red Hat training and certification I did. Excluding that, I make my hands dirty on the CCNF certification, that is called the Kubernetes one. So generally, I am delivering the training so on these kinds of DevOps tools and Linux programs in weekly and weekdays. Excluding that, I am a technical consultant as I work in the organization ProDevance Technology. In that platform also, I am exposure to work with this Terraform, AWS, and OpenShift, all these things in my bucket. So that's all about me. So let's go ahead to discuss our agenda of this webinar today. So I just represent in my first slide in front of you that is mentioned OpenShift, and a tagline I added over there. The OpenShift is a better way to develop and deploy the containerized application. So here we are going to discuss the high level overview of what OpenShift is. But prior to that, why we have to learn the OpenShift, why we have to choose OpenShift or Kubernetes, that is a question in maximum attendees what the previous session joined. So this what why we have to go with the step by step. So first we all have to know what exactly the containers, what exactly this containerized application, and how the OpenShift help to develop and deploy a containerized application. What are the limitations that we cannot manage with a Docker or Podman container runtime interface? We have to go towards the container orchestration tool. So individual terminology we have to come across. So let me move to my next slide. So our course objective, we are going to discuss here what is OpenShift, why OpenShift, and I'm going to explain the declarative architecture, imperative versus declarative commands, and what is the OpenShift versus Kubernetes, and what are the driving factors and features of OpenShift. So prior to start the session, I just make a representation here. So before 10 years back, 10, 15 years back, when the container terminology not comes into the market, how the all of the system administrator developer, how they are deploying their application. So I'm just mentioning in the left side of the slide, that is nothing but the traditional operating system, and right side I mentioned the containers. So if you can see this picture here, in the traditional operating system all the hardware components are connected. On top of that, host operating system is there. The host operating system terminology refers either it is a physical machine or it is a virtual machine, or you can say it is a public or private cloud based instance. Then to run the application on top of the host operating system, uh, the application libraries, two applications are running in this picture, let's say application A, application B. So to run this application on top of your host operating system, you have to include all the libraries, dependencies, binaries, okay, supported to that application. So how we are managing in the Red Hat Enterprise, we are managing with the RPM tool. And what the challenge we are facing, what are the limitations we are facing. So application, to run our application on top of our host operating system, we have to load the dependencies file, libraries file, any configurational file, or a static data file, you can say. So once it is loaded, then our application is going to be run. Okay, but the challenge is what, to run the application B, if it is not supported version what application A is supporting, so that version might not be supported with the application B to run. In that case, what the admin generally are doing, they are doing the rollback to the earlier version to run the application. And suppose, let's say, if any changes is happen, you are doing in the host operating system, you are doing any kernel patches, so that kernel version is not supportable to your application. So there is a your application may break and you cannot run your application in a high availability mode. So we have to move towards the containers. So when I am mentioning the word containers here, containers means you can imagine a picture of the transport container box. So suppose you are transferring from one location to other location, okay. So what you are doing, you are packaging, you are starting wrapping up your whatever your accessories. Let's say you have some glass materials, you have some crockery items, you have some books or wooden or your vehicles kind of thing. So you have to segregate different packages. So when you have to put inside the containers, and when you have to unwrap it, you can easily think that okay, these are the crockery items I have to handle in care. So you have to individually package your application, and you have to put inside the container loader. So using from that imagination, we are coming towards the picture that is nothing but called the containers here. So just I just gives one interruption, anyone is admitting is going on or not. Okay, and no one is facing any issue, let me go ahead. So yes, so containers are nothing but the imagination picture, as I say, it's a container that is a packer mover vehicle, you can say. You are packaging your whatever accessories you have, okay, you are segregating the things so that while you are just unpack that thing, so it is easy to understand. Similarly, in case of software, what exactly this container is, containers are nothing but packaging of your application, packaging of your application to run on top of your host operating system. So packaging our application means to whatever is needed to run your application A. Suppose, let's say it's a Apache application, or it is any database application, okay. So to run that application, what are the libraries file, what are the dependency file, what are the configuration file, okay. So it just a bundle inside the container, and it is running completely isolated from your host operating system. So I'm going to say here, you can define the containers in three perspective. You can define the operating system perspective, what container is. You can simply say that as a operating system perspective, you are going to define the container. Container is nothing but a process, like you are checking all the process with the ps-a command, the top command in your Unix or Linux like utility. Similarly, container is just a process running inside the sandbox, and container processes are completely isolated from the host operating system. So, like if you can say, compare the containers with virtualization environment. In case of virtualization, what we are doing, our application is completely running isolated from the host operating system. So virtualization, how it will do, virtualization means it will run multiple operating system simultaneously on top of single operating system, and the task is completely isolated from each other. So how the isolation is done in case of virtualization? You are using KVM hypervisor is the software over there. You people are using Oracle VirtualBox, VMware. Okay. So similarly, containers application also completely running isolated from the host operating system, but it will not load another operating system on top of this host operating system. Again repeating, the host operating system is nothing but either your physical machine, or it is a virtual machine, or it is any public and private cloud based instance. To run your containerized application on top of that, whatever your application need, the libraries, dependencies, binaries, static data files, configuration files, programming language runtimes, everything is packaged. And how it is just how the container processes are completely isolated from the host operating system. There is a feature of Linux called namespace. Okay, there is a feature of Linux kernel that is called namespace. It will do the isolation of the container process from the host operating system. So what isolation? You can say your user ID, interprocess communication, network. Okay, it is completely isolated from the host operating system. Next, if you are going to define the containers as a system admin perspective, what container is? Simply you can answer that container is just an application. Application means application can be your Java application, PHP application, Python application, or you can say any middleware application, or you can say Node.js, or you can say any database application. So container is just an application as a system admin perspective if you are going to define. And that containerized application is portable, means you can build and ship your containerized application easily to any environment. Why? Because it is consuming very low footprint hardware as compared to your virtualization environment. Okay, means in case of whatever the application CPU memory consumption, you can say it is very less, very less. So that's why you can say here portability is the beauty of container. Next, if you are going to define the container as a developer perspective, so you can mention that how we are packaging the application, how we are defining the code, how we are defining the code dependencies, how we have to create a container image, how we have to create a container image by using the Docker file or by using the builder tool, how we are building the image, and from that I have to run the container, how I have to pass my instruction. So that is nothing but the developer perspective. You have to know what container is, how we are packaging this application. So now the thing is, you are no dependency on the, it is completely isolated from the host operating system. Whatever your application is required, it is just carried with that. So your application is up and running without any challenge. So how we are managing the containers? So if I am asking a, just I am opening a notepad in the BIM editor here. Suppose let's say we all are the web admin here. Suppose my intention is I want to configure one Apache server. So what steps I need to do? So first my job is what? I have to install the package. I have to install the software. So to install the software must be available in the repository, or I mounted the ISO image file. So the software must be available in the repository. Then we have to proceed. Once the software is installed, software means that software is that package each consists of the libraries, the configuration files, the document root, any modular module content. Similarly, how you are getting your software from the repository to run your containerized application. Okay, to run the containerized application, you need what? One container image. You need one container image. And that container image, where it is available, that container image is available in the registry server. Okay, so now these all things we are look into details in our course curriculum. So to run the containerized application, container image is needed. Who created this container image? like we system administrator developer were creating the container image. How we are creating the container image? By passing the instruction in the docker file, or we are using the builder utility to build the container image. So once the container image is created, so what this container image consists of? The container image consists of to run your containerized application, because your containers are running from the container image. The container image having all the configurational setting, static data files, all the libraries or dependencies, any binaries it is required, or to run your application, to run your container, what is required, it is packaged in the container image. So you can say that container image is nothing but a blueprint to run the container. So from where I am getting that container image? Like I am getting my software from the repository, and I can install it with the dnf yum apt command. Then I have to deploy our application, web server application or MariaDB application on top of our operating system. Similarly, to run our containerized application, we require a container image. That container image from where I am getting? From the registry server. So what is registry server, and how many types of registry server are there? There are public registry server. Most of you might be aware the public registry server. Can I get any answer from the audience? Public registry server, docker.io. Okay, from Red Hat, registry.redhat.io. So your job is what? You have to pull the image from container image from the registry server and deploy your container on top of your host operating system. So organization having their private registry server also. So now, why I'm just mentioning these things here? Because if you want to deploy your containerized application in host operating system, okay, my host operating system, let's say it is a physical machine or it is a virtual machine. So how I have to get the containers from the registry server? Uh, so that is available in the docker or registry.redhat.io. So for that, to manage the container and container images, we are using the tool is what? Docker or Red Hat learns. The tool is called Podman. Docker is from Docker community. Podman is from Red Hat. Okay. So to manage the containers and container images, to get the image. So to pull the image, to log into the container, to build the image, okay, and to run our containerized application, to inspect our image, to start our container, to stop our container, to check the logs, we are managing, like we are managing our software with the yum utility, rpm utility, dnf. So similarly, we are using the tool. So containers means, some people can say container is nothing but docker. No, these are the tool used to manage the containers. Okay, let me back to the slide. So if Docker and Podman are the container runtime to manage the containers, so why I have to go for the OpenShift? Why we have to go for the OpenShift? What are the limitations of the containers we are facing? So containers provide an easy way, as per our previous discussion. Right now, I just added that point. Containers provide an easy way to package the application. Okay, it is the easy way to package the application and run the services. But think, if the number of containers managed by an organization or enterprise, you can say, it will grow. So the work of manually starting the containers, or manually we have to manage the containers on different hosts, it is very difficult. Okay, so what are the challenges? What are the challenges I can add here? What are the challenges if we are managing the containers? Multiple containers are running in our enterprises. So first thing is how we have to scale our application, how to scale our application, how to avoid the port conflict, how to manage them if the containers are running on multiple hosts. Okay, what happen if the host has some trouble, how to keep them running? Suppose my containerized application is running on a particular node. Okay, in a particular node my containerized application are running. So if that host has some trouble, how my application, how I keep my application running? So is there any self-healing feature, or how I have to update them? So when we are using the containers in the production environment, your enterprise often require that easy communication between the large number of services. There must be a resource limit on applications, okay, regardless of the number of containers running on them. There is a response to the application, okay, or react to the service deterioration. So how to easily scale, how to avoid the port conflicts, so to overcome. So enterprise often required a container orchestration technology, because the container runtime such as Podman, what I mentioned there, do not adequately address all these requirements. So the solution is what? The solution is what? Container orchestration tool. That is nothing but what? Kubernetes. That is nothing but what? Kubernetes. So Kubernetes is an orchestration service. It simplifies the deployment, management, and scaling of containerized application. Before I am defining the definition of the Kubernetes is an orchestration service, first thing I have to get a clarity that what exactly the container orchestration terminology is. Can anyone add your point here? What exactly the describe what exactly is container orchestration?
It managing the all the containers orchestration.
Managing all the containers we can manage with Docker, we can manage with Podman. So orchestrating means what? What is orchestration? We can manage the containers. If we go through the system administrator course, we can managing with the Docker run command, with the Podman run command. We can run our container, we can start container, stop container. We are managing the containers, we can building our container image. So what is the necessity of the container orchestration? Because enterprise often required what? Or enterprise offer required. So container orchestration is the fundamental enabler of the digital transformation initiative, and Kubernetes is the default standard container orchestrator, because most user organization and technology provider agree that running containerized application in production environment required what? Automation feature. This automation feature provided by container orchestrator, because microservice applications and cloud native application, many of these issues are commonly found on the distributed application, because traditional monolithic application were able to avoid many of these issues, because application service and function were running together on the same process space. But when your application is broken into multiple container, you need to consider the reliability, security, and the management aspects of running multiple services that connect using a network. So what is our solution here? To do the automation feature and self-healing feature, we have to use the container orchestration tool, that is called what? Kubernetes. Okay. So next question, when I am saying that, okay, to overcome the limitations of the Docker, because Podman or your Docker is come with the solution of Docker Compose, but that is not a professional or enterprise solution as such. So we are using the container orchestration tool, that is called Kubernetes. So yes, Kubernetes power the deployment and management of these container images across large cluster by providing the self-healing and auto-scaling feature. If Kubernetes is the orchestration tool, then why I have to learn OpenShift? Now I have to go to the next slide. What exactly the Red Hat OpenShift is? Okay, we are using the container orchestration tool, that is Kubernetes. Under the hood, OpenShift is using all the Kubernetes resources. But instead of Kubernetes, there is a certification program that is called CK. So why I have to learn Red Hat OpenShift? What exactly the Red Hat OpenShift is? So in my slide, I mentioned here Red Hat OpenShift is an enterprise open source container orchestration platform. It's a software product that include the components of the Kubernetes container management project, but adds productivity and security feature that are important to large scale companies. So what does it mean? What exactly container orchestration tool is nothing but our Kubernetes. Okay. And Red Hat OpenShift Container Platform 4 is a set of modular components and services built on top of Red Hat CoreOS and Kubernetes. And OpenShift Act adds the platform as a service. There are three types of service offering. One is IaaS. So let me write down here. So one is infrastructure as a service. Second one is software as a service. Third one is what? Platform as a service. So our OpenShift is Red Hat OpenShift. I just mentioned RHOCP, Red Hat OpenShift Container Platform 4, because we have to learn this course is designed our course and certification in version 4.6. So Red Hat OpenShift Container Platform, OpenShift add this one as a platform as a service. So what exactly the platform as a service? So OpenShift is Red Hat platform as a service offering means once it is deployed, OpenShift will take care of managing the underlying infrastructure component. Thereby, it will enable the developers what they do what they can do best. Means the OpenShift adds this platform as a service capability such as remote management, increased security, monitoring and auditing, application lifecycle management, and the self-service interface for the developer, self-service platform. In the last representation, when I am going to discuss the driving factors, I just come to the point that this is nothing but this is nothing but the features available in the OpenShift. That's why it is nothing but Red Hat platform as a service offering. So an OpenShift cluster, if I am managing the Red Hat OpenShift, so the obviously the self-healing and the auto-scaling feature is come with the help of what? The container orchestration tool Kubernetes. Or the container orchestration tool Kubernetes. But what OpenShift add the support? What the OpenShift add the support for the developer tool? Suppose I am giving one example. OpenShift is having built-in integration with the source control management SCM. It is having built-in integration with the SCM software, like for your example your GitHub. Second feature is what? OpenShift adds support for the developer tools. OpenShift has built in with the pipelines. OpenShift as built in with the pipeline that help the developer rapidly, consistently develop, build, test, and deploy their application. Third thing I am going to mention here, OpenShift help and manages the container runtime images. Container runtime images by providing a built-in registry. OpenShift is having built-in registry server. Okay. Fourth point I am going to add here, OpenShift come with the support of the software defined networking that provide the high level of networking capability to communicate the application running on different hosts, running on different node. So that we have to discuss in our course curriculum, software defined networking. Fifth point I am going to add here, OpenShift is API centric. OpenShift is API centric means it has a rich, well documented set of API that help us easily integrate our OpenShift with our existing infrastructure. And I can mention last but not the least here, OpenShift is giving it is providing the out of the box support for the project, for the teams. Teams means groups, for the users, Okay, so it is giving out of the box support for the project teams and users to organize and manage to the application. So we have to look each of these depth later in our course discussion. So that's why these are the thing. OpenShift adds support for the developer tools and Kubernetes power on the deployment management with the container images in a large production environment by providing the self-healing and auto-scaling feature. That is the Docker or the Podman utility, you can say. Inherently they are not capable of doing the self-healing or the auto-scaling. That's why we are going towards what? Container orchestration tool. Let me move to my next slide now. So to join this course, what are the course prerequisite? So the course prerequisite is all of you must have done with your RSCSA program. Means if you completed your certification, that is fair enough, but not mandatory. I'm mentioning here. If you completed your certification also, that is good, but equivalent knowledge is required. You must have to know sudo, SSH, yum, the basic knowledge of Linux administrator you have. Second thing is either you have to complete the Red Hat OpenShift 1 course, that is the basics of the containers and the DO 180 course. The course code is DO 180. If you completed the course and certification, then it is good. Or if you don't complete it also, certification is not mandatory. You have the equivalent knowledge. Equivalent knowledge means you have to know what exactly container, how I have to manage with the Docker, how to create the container image, what is container image, what is registry server. So all these things are discussed in your first course, Red Hat OpenShift 1 course. Before you are joining the DO 280 course, these are the course prerequisite. Then I move to the next slide here. I already mentioned what exactly the container is. So container is not virtualizing the hardware. So it is a virtualization of application instead of hardware. So containers are an isolated application runtime created with very little overhead because it doesn't require dedicated CPU, memory, network managed. These all are managed by your host operating system and it is running isolated from your host operating system. It optimizes the infrastructure speed and density. We can define the container in any aspects. We can say it is a process. We can say container is an application. So we can define in this way. And this is the comparison slide between the traditional method, between the virtualized environment and between the containers. So you can see in the virtualized environment, there is a hypervisor here. Then you have to load the operating system kernel, again all the operating system services, again what is your application is needed, all the libraries, binaries, dependency. So it will put heavy load on top of your base operating system. But containers are packaged the application with their whatever is needed to run their application. It is completely packaged their application and it is completely running isolated from your host operating system. This isolation done with the common operating system process where you are running your containers. So this isolation is done with the help of namespace and the same kernel feature control group managing the resources of the running containers and the security feature also coming with the AC Linux. So this is the three differentiation slide between the containerized, traditional and virtualized environment. Next is what I am not going to the day wise schedule right now. At the end, I have to mention the training program and duration. So I have to come to the Red Hat OpenShift now. Okay. So before I am presenting this slide, you can see this is nothing but a OpenShift software stack. So in this OpenShift software stack, anyone can imagine. First, you understand Red Hat OpenShift is a flagship products of Red Hat using the OpenShift container platform and it is platform as a service offering of Red Hat. So it is running on top of core OS. I have to come back to each thing. So prior to that, I want to demonstrate the architecture. As I mentioned in the agenda, what exactly the architecture of OpenShift. Because any course you join or learn, you have to get clarity on the architecture. Suppose just one example. If you are good, all of you are Linux admin here. So if I can say that, okay, what is the default cell in Linux? You people can say bin bash is the default cell of the Linux, okay? And what is the core component of the operating system? You can easily say that kernel is the core component of the operating system. And what is the terminal we are using? Genome terminal, because we are familiar with the architecture. Because we are familiar with the architecture. Similarly, in my presentation slide, what is the OpenShift cluster architecture? To get you understand, I'm just mentioning in the OpenShift architecture. Some people might be know the Ansible. When the architecture terminology come, you people can answer, okay, control node is there, managed host is there. Similarly, in OpenShift architecture, there is a thing, there is a, in this architecture there is a terminology. I am saying here node. Okay, I am saying here node. Before I am just mentioning what is master node and worker node, first you all have to know what is node. So node means what? Node is a server that hosts the application in the OpenShift cluster, where you are hosting your application, where you are running your containerized application. That server is nothing but called what? Node. And in our OpenShift architecture, how many types of node are there? There are two types of node. One is called one is called master node, or some admins say that control plane node. Okay, control plane node. Second is what? Worker node. And some admins say that compute node. Compute node. And sometimes you are getting the answer in my OpenShift. My friends are saying there are three types of node. Can you tell me what is the third node? Infra node. So let's go and discuss what exactly the master node, the worker node, and the infra node. So master node is called the control plane node. Let me back to my slide again. So this is nothing but called the master node. So master node or control plane node, what exactly this node is provide? This node provide the basic cluster services such as API and controller. Means to host the Kubernetes control plane component and manage the cluster. Manage your entire cluster is done by the master node. It provides the control plane, Kubernetes control plane component. That's why the alias name of a master node is control plane. It is controlling all the resource of the cluster. Okay, so how it is controlling? It consists of the control plane component. With the help of the control plane component, it is managing, okay, your cluster. It provide the basic cluster services, API and controllers. API and controllers. The four control plane component are what? API server, scheduler, controller or control manager, or etcd. So what exactly this API server is now? What exactly this API server? Let me, I'm just giving one small example. User means any system administrator, developer, you, me, anyone. User usually interact with the API server. It is the only interface. API server is the only interface where we developer and system administrator communicate with the master. And once we make a communication to create a container, let's say, then the API server instantly create a desired state of configuration in the etcd. So etcd is what? Etcd is a database where all the configuration requirement are stored. Instantly the controller comes to know that a new desired state of requirement has come up. Then the controller communicates to the scheduler that which is the best system to orchestrate my container. So scheduler will decide. You cannot decide that in my cluster I want to deploy my containerized application on the node, but you cannot decide on which node. because in my cluster 5 nodes are there. Who will decide? The who will schedule? The scheduler will decide that in which node your pod is going to be placed. I'm using the terminology decide. Kubernetes scheduler decide. It will not place. People are thinking that scheduler is placing my pod on the node. No. Okay. Scheduler is placing. I'm not using the pod terminology here. I'm just using the containerized application. Okay, because individual resource I will explain in detail in my course. So to run your containerized application on which node, who will decide? Scheduler will decide. So we have to interact with the API server, then control manager is controlling. Suppose node controller will take care of the node part. Replication controller is there. It will check that all the time in your cluster my 5 application is running at all the time. If one application is deleted, automatically self-healing feature. So how I know if my, because container is very lightweight process, it can create it, deleted, start, stop within a fraction of second. Okay. So if a my container application deleted, okay, so how I have to know how who will do the self healing feature? I'm using the orchestration tool, but how I have to control that one? There is called replication controller. Then all the type of resource definition. So API server, one by one I am just telling all the definition now. API server is responsible for orchestrating all the operation in the cluster. It exposes the Kubernetes API, which is used by the external user to perform the management operation on the cluster. So to deploy any application, to scale any application, first you have to log into the cluster. Can anyone log into my cluster? No. You have to log into the cluster as a authenticated user. Might be your organization using LDAP authentication, might be they are using Keystone authentication or HT password or OpenID Connect. So once you want to log into the cluster with the API server, you have to give the API URL. Then you are performing the management operations in the cluster. So everything in the container, whatever you are in the cluster, the orchestrating operations is responsible which component? API server. Next component, what exactly this controller or controller manager will do? The controllers are available to take care of different area. Your node controller take care of node. If a node is become unavailable or get destroyed, if the replication controller assure that desired number of container are running at all the time. 5 containers means my agenda is my application is run in a HA mode. Okay. In I have to make my environment agile environment. So for that, there is various controllers are available. Next component of the master node is what? Scheduler. Scheduler is what? It identify the container need. Suppose, let's say I'm giving here to run my containerized application. Suppose I want to deploy one Nginx application or Apache application, whatever. So to run my Nginx application in your cluster, I need this much of CPU. Suppose let's say I want a 10 millicore of CPU. I need the memory of 25, okay, 25 maybe byte, okay, and I have to need the storage of 5 GB. So now to run my Nginx application, containerized application, I need this much of resources. But if your node capacity is 3 GB, okay, can I run my container on that particular node? I cannot. Okay, so how I have to know to run my Nginx application with this much resources is available in which node? Who will decide? So scheduler will identify the container need to be placed on which node based on its size, its capacity, how many container already running on the node, certain condition like you can say so it is just used to identify the right node to place the container based on the container resource requirement. the worker node capacity, any other policy and constraint such as node affinity rules, performance, taint toleration, all these things we are going to cover. So this is decided by whom? By the scheduler. Last component is what? It's CD. Its CD is what? It is a database. It is a database that store the value in a key value format. So many of the container created, deleted on daily basis. Which application on which node? What time it is loaded? All these resource definitions and configuration stored inside the etcd in a key value format. That's why you can say the default file format OpenShift and Kubernetes is using YAML file format or JSON. Next, worker node. In this worker node or compute node is what? Where you are running your containerized application. Where I am running my containerized application. And in this worker node, I am just specifying kubelet, proxy and CRI. What is this kubelet, proxy and CRI? So scheduler is deciding where to place the application. But who will place the application on the node? Kubelet. So what exactly this kubelet is? Kubelet is an agent that run on each node of the cluster. I am saying each node. Okay, I will give in more detail. It will run in the master node also. In this picture, it is not in the master node. But remember that kubelet is an agent that run on each node of the cluster. It listens the instruction from the kube API server and deploy, destroy the container on the node when it is required. Cube API server fetches the status report periodically to monitor the status of the node and the container on them. Means they are saying here, excluding this API server, none of the control plane component can communicate directly with kubelet, and kubelet also not communicating with any of the component in the master node. Kubelet cannot communicate with the scheduler, controller and the etcd. It is only communicating with the API server. So kubelet is an agent and only API server can communicate with the kubelet irrespective of this. Okay, so whatever the scheduler, controller, etcd, they have to interact with the API server communicating with the kubelet. So kubelet is an agent that run on each node in the cluster. It listens the instruction from kube API server and deploy, destroy the container on the node when it is required. And this kube API server fetches the status report from the kubelet to monitor the status of the cluster and the container on them. Next, what is this? To run the container image is required. Okay, so for that, how I can get the container images? So earlier, up to Kubernetes 1.18 version and OpenShift 3.11 version, we are using the Docker for the software or image packaging. Now we are OpenShift 4 onwards, we are using what? CRYO, container runtime interface with open container initiative, CRYO. So what exactly this CRYO is? CRYO is an implementation of the Kubernetes container runtime interface to enable the open container initiative compatible runtime. Means you can use the Docker as a runtime from the Kubernetes. You can use the Rocket, Drawbridge. Okay, so now it is supported the multiple container runtime interfaces. Okay, like you can say my libpod, it is used by the container runtime for the podman. Okay, runc, it is used by the docker service. Rocket from the core operating system. So now not only with the help of the docker, we can manage with the container runtime, Kubernetes container runtime interface. Okay, so which will allow various runtime. We can use any container runtime that satisfy the container runtime interface, like runc by the docker service, libpod used by the podman, rocket, drawbridge, lxc, all sort of thing. Last but not the least, proxy. How the containers are communicated between. If they are running on multiple hosts, multiple node, how they are communicating. So there is a service called kube proxy. Okay, so how is the pod communication, how in the node to node, how the applications are communicating, that we are going to discuss. What are the resources are used, all these details we have to discuss in our DO280 OpenShift Administrator 2 training program. So this is just the slide how the master node and how your container is running using the container image. And we are saying what? We are using the terminology here, pod. So what exactly this pod is? Pod is nothing but my containerized application. Okay, so my containerized application running on a node. So why it is mentioned pod? So pod is represent a collection of container that share the resources such as IP address, your persistent storage volume, or your network. It is, you can single word you can say, pod is the basic unit of work for Kubernetes. So we are not using the terminology container. Container, where the container are running. One container or multiple container. That is nothing but called what? Pod. Okay. In the Kubernetes or OpenShift, the basic unit of work is called what? Pod. Okay. So this is the master plain component node. Whatever I discussed, I just added all the descriptive theory over here. Last but not the least, I have to explain what are the driving factors. Okay, and what are the driving factors before the driving factors. Now you understand better what exactly the difference between OpenShift and Kubernetes. And I'm just repeating one more time. Okay, what are the DevOps tool that OpenShift support? I just added this point here. Okay, OpenShift comes with the integration, built-in integration with the source control management. GitHub means what? If a developer is writing a source code and an image is available in the registry server, we can do the deployment using the S2I. S2I. Second thing, it is built-in integration with the pipelines. Third point is what? OpenShift is having inbuilt inbuilt registry server. Okay, inbuilt registry server in the sense, inbuilt registry server means it will give your container runtime images to deploy your application. Okay, OpenShift is API centric. So if you compare the OpenShift and Kubernetes, you can say here that so OpenShift is what? Product with the paid support. OpenShift is a, if you compare OpenShift and Kubernetes, it is product or project. So OpenShift is a product with paid support and Kubernetes is what? Open source project. If you are asking what is the supported operating system, the supported operating system earlier up to 3 version, it is Red Hat Enterprise Linux. But now core operating system. What is core operating system? Core operating system is nothing but it design, you can say simply container Linux. It is designed only to run the containerized application. Immutable operating system where we can install our OpenShift master node and worker node. Okay, so we have to discuss in details what exactly the core operating system. If I want to make any changes, how I have to make. Then if you can ask for the security, yes, OpenShift is very strict. Built-in authentication authorization model, integral role-based access control, all this security in OpenShift. Kubernetes, if you compare, Kubernetes is less strict. Service provisioning, you can say with the help of in OpenShift operators or template. At the terminology also we are going to discuss what is operators, what is template. And if you compare with the Kubernetes, you can answer Helm. Okay, deployment approach in the OpenShift, you can come across deployment config, deployment, but in the Kubernetes, there is no resource called deployment config. You can come across with the deployment only. Then in OpenShift, it support expose our application outside the cluster, router and ingress. Okay. So there is no router concept, router resource in your OpenShift. Sorry, in your Kubernetes. It just only ingress. So if you want to compare, there is various reason comparable. Some case OpenShift is good, some case Kubernetes is good. OpenShift come with the image stream that is not in Kubernetes. OpenShift is having integrated with the pipelines, that is CI/CD. Okay, OpenShift is having the OC, okay, with the kubectl plus some convenient feature that is called OpenShift client. In the Kubernetes, you are using what? Kubectl. Then networking. So there is a native networking solution is available, Open vSwitch in our OpenShift, but in the Kubernetes, some components require the third-party plugins like earlier we are using Funnel, Calico, okay, or Weave Network. In the that third-party plugins are giving some components for the networking approach. So this way we can differentiate. Last slide I'm going to present now. What are the driving factors of OpenShift? Means what are the features? So this is the picture what I mentioned one by one point. So OpenShift is having the self-service platform. So what exactly the self-service means? Means developer can have the priority to deploy any kind of application using the template, using the source code, using the container image. So it is a self-service platform. Multilingual support, OpenShift support Java, Node.js, okay, PHP, Perl, Ruby, etc. Third point, third driving factors, automation. It automatically rebuild the containers, redeploy the containers once the source code or the container image change. Okay, that we have to discuss with the S2I feature. Next is what? Collaboration and multi-tenant. Collaboration, it allow you to share the project, pods, nodes, migration. Okay, multi-tenant. And multi-tenant means what? You can work with multiple projects. Okay, multiple projects with different level of security, in which project which user having what role, we have to cover that one. Next is OpenShift is standard based web scale. Means you can say OpenShift provides the container multi-tenancy distributed application platform to handle the increased traffic on demand. So without any downtime, application is up and running 24 into 7. Open source, OpenShift is open source, means there is no vendor lock-in. Okay. Next, OpenShift give the enterprise grade support. Last one is nothing but the security. It provides the multi-layer security using the AC Linux, using the role-based access control, integrate also with the external authentication system like your LDAP, OAuth, OpenID Connect, Keystone, etc. So these are the driving factors of OpenShift. So next, this is the session in a minute slide, whatever we discussed, okay, that we are going to brief in our course, Red Hat OpenShift Container Platform based on Red Hat Enterprise Linux Core OS. Okay, earlier it is only RHEL, but now you cannot install. It is completely the Core OS community is acquired by Red Hat OpenShift to deploy the containerized application. And not only the dependency on the Docker, we have to start the Docker daemon, stop it, nothing. It is comes with the container runtime interface with the open container initiative, container engine, and Kubernetes as the orchestration tool. Red Hat OpenShift 4 provide a number of services on top of Kubernetes, such as internal container image registry, built-in registry I mentioned, storage, network provider, centralized logging and monitoring. In OpenShift 4, now we are coming with the features of the earlier we are configuring the metric subsystem installing separately. Now it has come at the time of installation. Prometheus is pre-installed in OpenShift Container Platform 4 version. Then we have to discuss, I'm not pointing out this operator terminology, so I'm skipping this word here. In the training program with practical, I will explain you. Operators is the new feature in Red Hat OpenShift 4 that will package the application which manage the Kubernetes or OpenShift resources. So the operator lifecycle manager handle the installation and management of operator. So just for the time being, you can understand that operators are nothing but the human application knowledge codified in a code to manage the resources in the cluster where come across the operators. So this is all about the course curriculum, means webinar session. I have to mention you now the skill path. So what is, as I mentioned in the discussion, the prerequisite. So this is the admin skill path. If already you are working professional in the OpenShift, you can choose. There is two skill path is there: admin skill path and developer skill path. Okay, admin skill path and developer skill path. For that, this course is first prerequisite is you must have the basic knowledge of containers. Okay, how to what is container, how to manage the container with the Docker. Okay, what is the challenges of the containers, how to create the container image, what is registry server. So these all things are covered. What are the OpenShift resources? This is a 3 days of training program with your certification, and it is a part of your Red Hat certified architect certification. The course code is DO180, exam code is EX180. If you are not write the certification, you have the equivalent knowledge on these aspects, you can proceed directly the webinar conducted on the Red Hat OpenShift Administrator 2, that is operating a production Kubernetes cluster. This is a 4 days of training program right now with your training and certification. Course code is DO280, exam code is EX280. Okay, 3 hours certification, EX180 is a 2 hours certification program. So in this course, in the 4 days, what we have to learn, you have to learn all sort of things. I just share you a course book, the details what we have to cover here. This is your course book you have to receive once your registration is done on this course. So first you have to describe all the resources of OpenShift. I'm just saying in my small introduction what is pod, what is node. Okay, but you have to know what is deployment, what is image stream, what is operator. So first is this chapter. Second chapter, you have to verify the health of the cluster. If any issue is there, if your node issue, pod issue, why your application not running, you have to fix it, verifying it, troubleshooting it, so that you are comfortable in the day to operation in your real time project work. Third thing you have to discuss about the authentication authorization. How you have to, what authentication method you have to configure to log into the cluster to perform the task. What is the role based access control? I use the terminology RBAC. So that comes into the authorization section we are going to discuss in the chapter 3. Fourth chapter, we are going to configuring the application security. Not only we are giving with the access based security, our pod, our containerized application, how it will run securely, how we have to work with the secrets, config map, or service account, that we are going to cover. Next chapter, we have to discuss more on the networking part. What is SDN, software defined in networking, how to troubleshoot any network issue, not application related issue, network issue, routing, all sort of things, network policy, how we have to route, that is our chapter 5. Sixth chapter, we are going to cover pod scheduling. Okay, in the pod scheduling, how the scheduler decide. I'm saying that capacity, identify the node capacity, some affinity rule, some prioritizing algorithm, some resource limit. So that the how to do auto scale. Okay, the how to do manual scale, these are covered in chapter 6. Seventh chapter, we are just discussing what exactly the OTA deployment, how to do the describing the cluster update. And last chapter, we are going to cover the thing how to do the things not only with the command line utility OpenShift client, how we have to perform the thing using the web console. So these are 4 days, 8 chapter. Each day, two chapter is enough to cover. And the last chapter is a quick summary and comprehensive review. That slide, that's why to share you the book and showing you, that's why I skip this slide presentation. Day one, day two, day three, how we have to cover. Now it is a 4 days of training program. Once this one is you are comfortable with all these aspects, you know all the things. If you want to go for the installation, Red Hat provisioning one installation course, that is do 322. No certification is there for that course. And administrator 3 level course is also do 380. No certification program for that, but yes, learning or course program is there. So any admin go to the developer skill path. I want to know the CI/CD, GitHub, what is S2I, how to do the deployment. So prerequisite 180 is mandatory. You have the knowledge. Then the development course is DO 288, and both the course is having the certification program. Okay, so this is nothing but the development skill path. So that's all about your training, training duration. And all this training duration, you are getting the lab for 90 days. You are getting 1+1 attempt on your registration from the Red Hat lab, so you can practice and make certification, and you can work with all the gaining all the proof of concept. You can get here all the practical scenario, so which will help you to the next level in your environment to proceed. So that's all for today's agenda. Thank you. Let me check in your chat window. If any queries there, I definitely get back. So let me back to the queries. Okay, Pusparaj. In Kubernetes also we can deploy our application, right? So what is the difference? I hope, Pusparaj, I mentioned now you can understand what is the difference between OpenShift and Kubernetes. Okay. So Kubernetes is nothing but a container orchestration tool with the self-healing and auto-scaling feature. OpenShift is using all the Kubernetes resources, but OpenShift comes with what? Built-in integration with the SCM, CI/CD pipeline. Okay, so you can mention that you cannot do with the S2I deployment in the Kubernetes environment. Yes, you can use the kubectl create command, kubectl run command. Okay, so same resources, same pod service, these resources OpenShift under the hood using the Kubernetes resources. Okay, so slide presentation slide we cannot share, but yes, session recording we can share. Okay, it is for official use. Yes, yeah, please. Any queries? Someone raise your hand. I can see here.
Yeah, hi Mitali. Hi, this is Dwaipayan Saha.
Hi, Dipan.
Yeah,
Nice to meet you in this forum. Yeah,
yeah.
I
Thank you,
personally know
thank you.
you. Yeah, please.
Yeah. So, I'm very interested to join the OpenShift program. The thing is that while long back while we did that was the older version. I think 3.5 or 3.4. I think we did
3.9. Okay, if I
3.9. Yeah,
remember in
yeah.
course you completed,
Yeah,
that
it
is
was
3.9.
3.9. So that time I have done for only the OpenShift 1. So is it possible, like from course or either from you, if you can share a little bit of the I mean to say the uh,
Light on the administrator one course.
yeah,
Sorry for the
administrator.
interruption. Okay, let me
Yeah,
clarify that aspects
one
also.
and two also, one and two both. Like what are the contents of one and two? I mean to say the advance as well as the first one. So both the things.
This one
Yeah,
you are
yeah,
saying. Okay,
yeah.
so let me add my point. Some students are directly enrolling for the do 280 administrator course. Okay, because they already have some idea on the Docker containers, they don't want to invest on that aspect. So I agree that point. Okay, so if you go and plan from the scratch, if you are a fresher, Definitely. And a second thing I can add here, okay? So yes, before starting the DO 280 training module, I can help you with all this session, means the basic things. And in the OpenShift class, when it is started, 1 hour specially, I just explain what exactly in OpenShift 1 people learn there, how to deploy the application. Okay, even if you already certified in the earlier version, not in touch, once you are going through that concept, then it is easily you have to proceed your OpenShift administrator to program. Okay, that help we can do.
Yeah, that's what. Yeah, exactly. Thank you. Thank you. So I am interested in OpenShift 1 as well as the advanced version OpenShift 2.
Yes, yes,
So yeah,
yes.
so one is nothing but as we did in a certification, like deploying the application into the pod
Exactly,
as
exactly.
well as
What you did in the 3.9, you
yeah,
are installing metric subsystem, you
metric.
are
Yes,
ST password. Okay,
yes,
so
yes.
OC new up command, same thing
Ah,
is done in the 180. Okay, if you,
yeah.
well, I just highlight that point again before I
Okay.
proceed to the TO280.
Okay. Thank you.
Okay,
Thank you.
yeah, and
Thank you.
version is 4.6.
Okay. Now the current version
Current
4.6.
version in the market is 4.10,
4.6. Okay.
but Red Hat is giving the training and certification on 4.6.
4.6. Okay. So the first part is for 4 days training, and the second part, that is the advanced part, is for 3 days, right?
4 days.
4 days.
This one
Total
is
8 days.
three, yes, 4 days, 8 days total.
Okay. 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 Thank you.
Any other queries?
Yeah, hi Mitali, this is Shandu.
Yeah, please.
Yeah, even in this